geobyte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this: to project a body of mass m from Earth's surface to infinity. To project the body to infinite distance, that body must be projected with a velocity called escape velocity. Okay, the required kinetic energy is, assume the radius of Earth is RE. G is the acceleration due to gravity on the surface of the Earth. Okay, as you know, the kinetic energy K in terms of escape velocity half into mass of the body into square of the escape velocity. Okay, it must be equal to G into mass of the earth multiplied by mass of the body dividing by the radius of the earth. Okay, from this I can write that K equal to G capital M small m by RE. But as you know, the acceleration due to gravity G on earth surface is Gm by Re square. From this I can write that Gm equal to Gre square. Therefore kinetic energy K equal to Gm equal to G into Re square into small m divided by Re. You cancel the 1 Re. Finally, the kinetic energy to be maintained with the body to travel with infinite distance is G into M into Re. That is the answer. G into M into Re. Look at the option C. Option C is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. It is asking like this. A satellite revolving around a planet in stationary orbit has the time period 6 hours. The time period for the satellite T1 equal to 6 hours. Okay. The mass of the planet is one fourth of the mass of the earth. Mass of the planet m1 equal to mass of the earth by right one fourth, right, 4. The radius of the orbit of the planet, you're asked to decide the radius of the orbit of the planet. Given radius of the geostationary orbit for the earth is, the radius of the geostationary orbit for the earth is, that means radius of the earth is given Re, it is equal to Re equal, let it be R only, let it be R only, R equal to 4.2 into 10 power 4 kilometers. As you know, on the earth surface, the time required for satellite for revolving is equal to time required for earth for completing one revolution about its axis. That is the time period, right, for the earth is to rotate about its axis, let it be equal to t equal to 24 hours. 24 hours. Okay. Now as you know according to according to Kepler's law, Kepler's law, square of the time period equal to 4 pi square r cube by gm. This formula we have clearly discussed while we were discussing the theory. Do you remember? Yes. From this I can say that square of the time period equal to 4 constant, pi square constant, g constant. This entire Part T is taken as constant. Then it is some constant k, where k equal to 4 pi square by g, right, into r cube divided by m. From this I can say that t1 square equal to constant k into r1 cube by m1, and t square equal to kr cube by m. Then t1 square by, let us take another slide, t1 square by t is equal to, look at the t1, kr1 cube by t1 square equal to t1 square by, एक minute, t1 square by t square is equal to kr1 cube by m1, kr1 cube by m1. Similarly, t2 t square equal to k into r cube by m, r cube m. So from this I can write that t1 by t whole square, constant k is cancelling, here it is r1 by r whole cube into m by m1. Okay, so t1 by t whole square is equal to r1. Look at the r1 value. R1 value is Dama. Okay, R1 value, is it R1 given? R1. You're asked to decide the radius of the R1. You need to decide R1 only. R1 by radius of the earth is 4.2 into 10 power 4. 4.2 into 10 power 4 whole cube into m by m1. M is mass of the earth divided by m1 given as m by 4. M by 4. So it is better to write the time periods also. The T1 is given as, 6 hours divided by T is 24 hours whole square. Now we simplify this value. It is 1 by 4 whole square is equal to R1 cube by 4.2 into, otherwise 8 minute, R1 by 4.2 into 10 power 4 whole cube. Here m cancel, m is cancelling. Finally 4 goes up. So here it is 1 by 4 square into 1 by 4. 1 by 4 square into 1 by 4 means I am bringing this 4 to this side, equal to R1 by 4.2 into 10 power 4 whole cube. It is 1 by 4 cube, right? 1 by 4 cube equal to R1 by 4.2 into 10 power 4 whole cube. Okay. Now you write, you can write R1 by 4.2 into 10 power 4 equal to 1 by 4. 1 by 4. From this R1 equal to 4.2 into 10 power 4 divided by 4. It is approximately 1.05 into 10 power 4. That is the radius of the right orbit where the satellite is revolving. 1.05 into 10 power 4. Look at the options. 1.05 10 power 4. Option B is absolutely correct. Okay. The units are kilometers because R we have taken in kilometers, right? Since R, the radius of the earth is 4.2 into 10 power 4 kilometers, therefore R1 also in kilometers. Got that point? Yes. Then let us take the another important problem. Look at this problem. It is asking like this. A simple pendulum doing small oscillations at a place or height above the earth surface has time period t1 equal to 4 seconds. t2 would be its time period if it is brought to a height which is at a height of 2r. That means t1 is the time period when the height of the orbit is equal to radius of the earth from the radius earth surface. Similarly, t2 be the time period when the height of the simple pendulum is twice the radius of the earth surface from the earth surface. Choose the correct relation. You are asked to decide correct relation where r equal to radius of the earth. As you know, the time period for simple pendulum t equal to 2 pi into root over L by G. This G equal to Gm by R square on earth surface. On earth surface. Above the earth surface, G equal to Gm by R plus H whole square. It is above the earth surface. Okay. Since the simple pendulum is operating above the earth surface, let us take this formula. Then time period t equal to 2 pi into root under L by G. Gm by R plus H whole square. Okay. Let us take another slide. Time period t equal to 2 pi into root under L by Gm. Correct? No? Gm. This R plus H whole square goes up. Okay. Now at H equal to R, at H equal to R, time period is T1, that is equal to 2 pi into root under L by Gm into 2R whole square. R plus H equal to R plus R is becoming 2R. Similarly, at H2 equal to 2R, the time period T2 given 2 pi into root under L by Gm. Here it is R plus 2R. It is 3R whole square. So the T1 can be written as 2 pi into 2R into root under L by Gm. Similarly, T2 equal to 2 pi into 3R into root under L by Gm. Therefore, the T1 by T2 is equal to what? 2 pi into 2R into root under L by Gm whole thing by 2 pi into 3R into root under L by Gm. Now let us cancel L by Gm, R, 2 pi. Finally, it is T1 by T2 equal to 2 by 3. From this, I can write that 3T1 equal to 2T2. That is the answer. That is the relation between the T1 and T2. 3T1 equal to 2T2. 3T1 equal to 2T2. Look at the option D. Option D is absolutely correct. Understood clearly? Yes.
Geobyte.